Hi everyone, I'm Shash and good morning to you all. So what I really want to show you today is a quick glimpse into the future of skills training and how three key technologies are going to shape the future of skills training: virtual reality, motion tracking, and haptic feedback, and a small case study of how this can be applied within composite manufacturing. So more on this later. Let's talk a bit about composite manufacturing. Let's talk about hand layup. Yes, day by day we are moving towards complete automation of the layup process, but the reality is that majority of complex composite parts are still manufactured using hand layup. So hand layup is where we deform flat sheets of pre-impregnated woven fibers into complex shapes. This is a process that requires a highly skilled and experienced workforce. It's a very labor-intensive process. Because it's so labor-intensive, the process is prone to an immense amount of variations, which prohibits us from obtaining consistency between the final composite parts produced. So just to emphasize this issue to you, let's have a quick look at how a couple of expert laminators with years worth of experience went about laying up a very simple composite part as shown in this slide. See if you can figure out the variations between the two laminators. Okay, if you looked at the video closely, all right, both laminators started off in a very similar fashion, and then they started using completely two different types of tools. They were using different hand gestures to apply pressure, and the order in which they were applying pressure to this mold was completely different. So now you can start to imagine the amount of variations that start to kick in when you start to increase the complexity of the composite part that needs to be laid up. So the question is that, is there a solution to this? Can we standardize this messy process, or can we attack it at the core? Can we standardize the delivery of training to both expert and novice laminators? So now I'm going to show you a small demonstration of how I believe this can be achieved using two of the three technologies that I showed you at the beginning of the presentation. I'm going to take a sit for a while so you can have a look at this. Hi, this is Shash. Since this is a very short presentation, let's dive straight into it. So what we have over here is the Oculus Rift, a virtual reality headset, which allows us to perceive depth. And this little gadget over here is called the Leap Motion. This is a hand tracker. Once you combine the Oculus Rift with the Leap Motion, you can do cool things with it. Let's see what we can do with this setup. So now I'm inside this virtual layup room. I can look around this virtual room. If I bring my hands forward in front of the Leap Motion, you can see my virtual hands. It can track my hands. And in front of me is a virtual prepreg, a virtual mold. If I look up, there is a virtual screen over there which is instructing me as to what to do. So currently it's telling me to pick up this virtual prepreg and place it on the mold. So let's do that. So that's me picking up the virtual prepreg. You can see I can rotate it in different directions. I can move it up and down. So let's see if I can place it on the mold. Right, so now I've placed it on the mold. So now it's asking me to position my arms like this. So let's do that. Right, and now I'm supposed to apply pressure. Right, now if I move my head over here, what you can see over here is the dibber, this red color tool. So the dibber was founded by Helen Jones, one of our students from the CDT. She wants to have a multi-purpose standardized tool that we can use during hand layup. Let's see what we can do with the dibber. Let's see if I can pick up the dibber. There we go. So now it's asking me to apply pressure to this part of the prepreg. So let's do that. You can see the prepreg deforming onto the mold. What we have over here is a virtual prepreg draped onto a virtual mold. Okay, thank you for your attention. So some of the obvious advantages of such a system is that now it allows us to reinforce muscle memory into laminators. Now we are minimizing the material cost that goes into training. At the same time, we are eliminating the need for a clean room environment to carry out your laminate training in. And last but not least, we are providing a platform in which self-learning can be carried out. So you no longer have to take your head laminators out of production to train your newbies. So I've just managed to finish this simulation out of conference pressure. I haven't really quantified this yet to see if this thing can actually create any muscle memory or not. That's going to happen immediately after this conference. I'm also working on providing real-time feedback to laminators using a technology called Kinect Fusion. I don't really have time to talk about this now, but if you want to know more about this or any of my other work, please do come and speak to me at my poster. I would like to give special thanks to Michael Elkington and Helen Jones for their contribution towards this work. If you have any questions, I'm more than happy to answer them now. Finally, thank you very much for listening. Thank you.